This is the second video in a 3-part series. The link to the first part is in the upper right-hand corner. I spent probably 2 or 3 weeks prototyping different designs. What I learned was it wasn't really that hard making a magnetic lock. It was a little more difficult though making one small enough to fit into the box that I was making. What I also learned is there had to be a way for the lock to reset itself, because it wouldn't really do for the lock to be able to be opened just by shaking it. So I started incorporating springs into the designs. At this point I was also still using bearings in some of my pivot points, and not only was this overkill, but they took up too much space. After trying out about 7 different designs, I settled on 3 for the box that I was making. My main lid lock is the smallest and probably the most complicated of the 3. I 3D printed the case and the lower part of the latch for the lock. The actual design and function of the lock is really quite simple, but the way I made it required several pieces to be made out of brass. Luckily, brass is soft enough that most of what I needed to do could be done with woodworking tools. I made these parts out of brass for a few reasons. 1, this is going to be a pretty high-end looking box, and having exposed plastic parts just wouldn't be cool. And 2, this is a locking latch. I didn't want to use plastic in the parts that would actually engage with each other to secure the lid shut. Because the entire lock had to be no thicker than 1/2 inch, every single millimeter counted. By putting a hole in this latch, the magnet was able to sit inside of it, which actually saved about 2 millimeters. Just a heads up, there's a few continuity errors in this sequence. I ended up doing 2 separate latches. They were so difficult to make, and the first one ended up being too small, so I had to redo it. I didn't film every single part of both of them. What you're seeing though is basically the entire process, just with 2 different latches, one of which was slightly different than the other. After finishing the brass hook of the latch, I epoxied it to the plastic arm. The magnet went in next. It was important while making these locks to make sure the poles of the magnets were all the same. While that epoxy cured, I started making the other visible pieces. I'm not really sure what you'd call these parts. One of them will be sort of the strike plate, and the other one will go on the lid of the box that will lower down and engage with the lock. Both of these parts will be screwed to the box itself, so I countersunk the holes. The lower part of the lock goes together like this. I used a torsion spring to make sure that the lock would reset itself. A small brass rod serves as a hinge pin. The torsion spring engages on a little tab that comes off the side of the movable arm, and another one that's on the outer part of the frame. A few drops of CA glue were used to glue on the outer part of the frame itself. The brass strike plate was glued on with epoxy. I went with a pin design for the part of the lock that would engage with the lower latch. I used the lathe and some files to shape the brass rod to make the pin. The pin needed to have sort of a bulbous end, so there was something for the hooks on the latch to actually engage with. The pin also needed to be somewhat bullet shaped, so it would move the latch out of the way when the lid on the box was closed. The runout you're seeing in these shots is because I have a chuck within a chuck. The actual pin itself is straight as an arrow. At this point, the pin is just friction fitted into that brass plate. I used some solder to complete the joint. I'm not a jewelry maker, so I imagine this could have been done better, but for what I needed to do, it worked just fine. And here you can see how the lock actually functions in practice. The magnetic key moves the arm out of the way so it disengages the pin. The shape of the pin moves the arm out of the way so that the hooks on the arm can engage the pin. This silly little thing was probably the most difficult part of the entire box to create. And of course I had to make sure that the magnets would be strong enough to go through the distance added by the wood. The drawer lock was a lot simpler, but it did have to provide two different functions. One, to provide means of securing the drawer, and two, to provide means of opening the drawer. As with the lid lock, the drawer lock was 3D printed with two halves and a moving arm. A spring also provides the return action. Because part of the arm itself would be visible, again I didn't want to have visible plastic. The round part on the left is the part that will be showing, so I decided to trim it in brass and wood. I epoxied on some cocobolo scraps for the front and back. After trimming the cocobolo flush, I did some further hand sanding and finished it off with paste wax. With that done, I glued the magnet into the recess on the arm. Next I installed the arm into the frame, and you can see there's a small piece of metal that was also glued in here to provide more magnet action. With the two halves together, I installed the return spring and tried it out. Like everything else, I had to get the drawer face sanded down to its final thickness, and to do that safely I needed to put a spacer block inside the cavity where the lock mechanism would go. I used spray adhesive to temporarily install this piece of walnut during the sanding process, and I did it that way so I could use an iron to release the glue later when I needed to get that block out and put the lock mechanism in. After getting the veneers sanded to their final thickness, I cut out the lock catch hole. The lock tab goes into a corresponding hole in the side piece just above the drawer. And that's how I made the drawer lock. The stash compartment is pretty simple but contains a lot of 3D printed pieces. After all the pieces were printed, I glued the magnets into the rotating arm. I used the magnetic key to make sure I kept the poles going the right direction. The rotating arm goes on a circular piece that gets glued onto the compartment lid. When I designed it, I added little notches so I could properly line it up on the lid. After the epoxy had dried, I installed the arm and then glued on the little keeper. Then I was able to install the return spring. Here you can see the function. The magnets in the coaster key move the arms out of the way, and then it can be used to lift the lid or false bottom up. The arm engages with tabs on the side of the compartment walls when locked. I trimmed out the visible side of the lid with black velvet. Finally, the lock tab framework was installed into the box divider assembly. And here you can see how it would function in real use. Of the three types of locks in this box, I would definitely have to admit that the stash compartments require the most technique. I hope you enjoyed watching how I made these locks, and I'll finish everything on the box in the final installment. Thanks for watching.